We are looking at solving simultaneous equations. Before now, you must have encountered solving simple linear equation where you have an expression like, say, 2x minus 5 equals to maybe 13, and you have to solve for x. If you look at an equation like this, here our x is said to be your unknown, and it's just a single one alone, just one term. Find x, and that will be very straightforward for you to do that. In a simultaneous equation, we have more than one unknown. You have more than one variable that you need to find. If you have two unknowns, you may need nothing less than two equations. You have three unknowns, you may need three equations. Our focus will be on solving simultaneous equations involving just two unknowns. And basically, we make use of two methods in solving simultaneous equations: the elimination method and the substitution method. Now, a typical simultaneous equation can arise from a scenario like this. You walk into a bookshop and you say you want to buy pen and you want to buy books, say exercise books, and you are told, oh, let's say rather you don't know the price of the exercise book. You simply ask them, tell the cashier, or should I say the cashier or the clerk, sorry, I need 3 pens and I need 4 exercise books. And they say, oh, 3 pens, 4 exercise books, that will cost you 50 naira. So, okay, 3 pens plus 4 books, that cost 50 naira. And some other person says, okay, I need 2 pens and 3 books. So, okay, 2 pens, 3 books. Oh, that would be 35 naira. But so far, you have not been told how much a pen costs and how much is one notebook. Here we have a pair of simultaneous equations, 2 equations with 2 unknowns. By solving this pair of equations, we'll be able to arrive at the price of 1 pen and the price of 1 exercise book. Let's start with the elimination method. How do we use the elimination method to find the price of 1 pen and the price of 1 notebook? The elimination method is simple, just as the name connotes. Simply means, oh, I have P and I have B, both of them not known to me. Can I do away with 1 and get to a stage where I can have an equation that has only B, and then I can solve that simple linear equation to get my B? And if I now know the value of B, I can bring it back into any one of these 2 equations to find my P. So let's get down to this elimination method. Now, in doing this, how do I eliminate? I'll look at equation 1 and equation 2. I say, okay, I decide I want to eliminate P. As you can see here, let me eliminate P. But for me to eliminate P, in equation 1, P has a coefficient 3. And in equation 2, P has a coefficient 2. First thing I do is to find a way to make sure the coefficients of P in the 2 equations are equal. And that can be done by multiplying the whole of equation 1. I'll multiply the whole of equation 1 by the coefficient of P in the second equation, that's equation 2. I multiply it by what? By 2. Which means I'm going to multiply the 3P, the 4B, and the 50 by 2. That way I will turn the coefficient of P here to 6. And if I do the same thing to equation 2, multiplying equation 2 with 3, that's the coefficient of P in the equation 1. That also makes the coefficient of P here to become 6. That's the first step. Let's see. We say multiply equation 1 by 2. That is the coefficient of P in equation 2. And multiply equation 2 by 3, which is the coefficient of P in equation 1. Now doing that, I'll say 2 times 3P, that will give me 6P, plus 2 times 4B, that gives me 8B. I say 2 times 50, that gives me 100. And you call that equation 3. So that's how we obtain the equation 3 we have there. And we now do the same thing to equation 2. Multiply equation 2 by the coefficient of p in equation 1, which is 3. So 3 times 2p gives me 6p. 3 times 3b gives me 9b. And 3 times 35 gives me 105. I decide to call this equation 4. Now, once we have done this, you will now notice that the coefficient of p in the two equations are now the same. So I can now simply say, oh, I'm going to subtract one equation from the other. Say, I say, okay, equation 4 minus equation 3. If I subtract equation 3 from equation 4, that would be 6p minus 6p. That would be 0p. 9b minus 8b will give me 1b. And then 105 minus 100 will give me 5. As simple as that. Some other person might say, oh no, I want to subtract equation 4 from 3 and say equation 3 minus equation 4. Again, 6p minus 6p here will give you 0p. That's gone. And then 8b minus 9b will give you minus 1b. 100 minus 105 will give me minus 5. Whichever one you use, if I divide both sides by minus here, that gives me my b as what? 5. So you can see that by eliminating p, we arrived here and had an equation that had nothing to do with p anymore. And that's where we get the name elimination method. Try to drive away one of the variables. You now have only one left, and then you can solve for that one easily. So you can see here we say subtract equation 4 from equation 3. That means 6p minus 6p, that gives us 0. 8b minus 9b, that gives us 9. That gives us minus b. 100 minus 105, that gives us minus 5. And of course, multiplying both sides by minus 1 gives us b as 5. So now we have obtained b. What about p? We'll simply take the value of b that we have, move into any of the equations we like, maybe equation 1 or equation 2, and use that to get the value of p. Let's see what we have next. So here we say substitute the value of b equals to 5 in equation 1. Equation 1 states that what? That 3b plus 4b is what? Is 50. It's okay. I'm going to put here b, which is 5. That's my 3p. And what do I have here? That's 3p plus 20 equals to 50. Of course, 3p here is what? 50 minus 20, which gives us 30. And we can easily solve here to get our p as what? As 10. So as you can see there, we have obtained that our p is 10 and b is 5.